All right, everybody, welcome to the Daily Space Weather. We've got exciting stuff today. A cosmic ray report, some major changes there. A huge filament in the northeastern limb right up here. Crown prominences. And lots more. We'll talk all about it today at the Smash News Network, least busted name of news. This is a 24-hour video from SDO. We're showing ionized iron and helium here. 193 plus 304 angstroms. We do also have a high likelihood of large solar flares, especially in this northeastern limb, the same place we did see the most recent X-class event. You may have seen this massive crown prominence. You can expect to see more of those in the coming year or two. As we creep closer and closer to solar maximum, we're still like possibly a year out from solar maximum, folks. I would say at least 9 months away from the peak of this solar cycle. Here's a great close-up of that filamentary activity there around the North Polar region. Here's an equatorial zoom real quick. Again, I would note this huge filament over here. It's getting named today. And here is the South Polar region. And you can see a crown prominence down there as well. It looks like it is starting to get a little bit unstable there. Huge plasma filaments all over the visible portion of the solar disk. Oh, I almost forgot. There's a close-up. How does that strike you? By the way, those crown prominences are very unlikely to become Earth-directed coronal mass ejections. Anyway, brief talk about the channel here. If you haven't checked out our homepage at smashomash.com, check it out. We built it for people just like you. It is the official homepage of the Smash News Network, least busted name in news. And welcome to the Neo-Renaissance. If you think that's some kind of a cult, it's it's a reemergence of critical thinking in the realm of science. And folks, it's important to understand that when it comes to space, when it comes to any science, oftentimes outsiders are the ones who have a tendency to advance things because of a multidisciplinary approach. So on that homepage, as well as below this video in the description, you can find links to some of our paid affiliate sponsor links. One of them is Hemp Lucid. Perhaps check out the stress stacks or the immune stacks or the mushroom gummies or the focus mushroom gummies, one of my personal favorites, as I became a pro athlete in 1999 in the realm of cross-country mountain bike racing. So I do know a little bit about fitness and nutrition. To see posts about fitness and nutrition, perhaps follow us over on Instagram. Links to the Instagram account as well on the homepage at smashomash.com. Today's featured product on the Amazon store is the Anthony's Organic Cocoa Powder. Yeah, it's raw organic cocoa powder. It is organic, non-GMO, for that matter. Are you paying way too much for cocoa powder that's not even organic and is GMO at the grocery store? Well, pick up a 5-pound bag and save a ton of cash there. I have no idea what the price difference is. It's a huge price difference, I'll just say that. Again, links below the video and on the homepage. And let's take a look at sunspots. Here's yesterday plus today in our SDO continuum. No major changes there. Although we do have 2 new groups. So there's a small group up here in the north. And here is another group that just formed in the northeast. The most likely place to see large flares remains in the northwestern limb. We've seen that uptick continuing. Here is your colorized magnetogram. That is yesterday plus today as well. That's August 6th, the whole day, and August 7th to date. Next, we'll take a brief look at volcanoes. I want to know what's erupting. What about you? Mayan continues to erupt and produce a 9,000-foot plume of volcanic ash. Also, Ibu exploding. About a 7,000-foot ash plume there over Ibu. It's a flight level 066, really. Semeru on East Java, Indonesia is a 15,000-foot ash plume produced. Dakono exploded and produced a 7,000-foot ash plume. Over Halmahera, Indonesia, Santiaguido in Guatemala exploding, flight level 140. Fuego in Guatemala exploding, flight level 160. No volcanic ash observed from Nevado del Ruiz in Colombia. Also Sabancaya, not identifying any ash. Also Ubinas. However, Pitan de la Fournaise also gracing our list here, which has been stable. Four volcano tectonic earthquakes over the past 24 hours. Ground deformation continues to detect the summit area inflated. So perhaps another eruption fixing to happen there at Pitan de la Fournaise. And let's go to seismic activity next. We'll cite quakes of a 5 magnitude or greater, like this 5.2 at Afghanistan to start out our list. That was at 13:23 Universal Time. Yesterday, South Sandwich Islands had a 5.7 and a 5.2. Those were only about 8 minutes apart there. Around 14:17 and 14:25 Universal Time yesterday afternoon. Japan had a 5.5 around 18:12 Universal Time yesterday evening. South Sandwich Islands had a 5.4 then. 5 minutes till midnight Universal Time. And last but not least, a 5.1 struck the India region there, around the Bay of Bengal Indian Ocean border. That was a 5.1 magnitude quake at 7:23 Universal Time this morning. And let's get back to space, because that is what the channel is about. We are spaced out here at the Smash News Network, least busted name in news. Here's the past 24 hours. That is SDO 171 angstroms. And it is the house favorite wavelength. Let us know your favorite wavelength in the comments. Thank goodness for the SDO. It is indeed one fantastic instrument. Now, like I said earlier in the video, the most likely place to see continued large solar flares is indeed up here in the northwestern limb. There is quite a bit of plasma instability happening up there. You could see additional X-class flares. And before we get to coronal holes and so on, let's take a look at some stats. The 10.7 centimeter radial flux now at 174 solar flux units. No big changes happening there. No big changes happening to the sunspot number. So there's the 1 year graph. The black line is the radial flux. The red line is the sunspot number. And if you are a regular viewer of the channel, you'll know how proportional these are. Check it out. Most troughs are associated with a direct proportionality there. Now let's talk about CME impacts. We are expecting one tomorrow early in the day from this high-speed coronal mass ejection that was associated with an X-class solar flare. It's expected to be a brush past or perhaps a glancing blow, not anywhere near a direct hit. The dense core is well off to Earth's west, as depicted in this NASA forecast. So that's NASA's Enlil spiral. And here's NOAA's Enlil spiral. So very similar modeling there. I would tend to agree with those. We don't expect to see anything higher than a KP 6.33 from that. And if I had to bet, which I don't, I would say it'll probably only be like a KP 5.33. So that's NOAA's forecast. And you can find that yourself on the Space Weather Enthusiast dashboard if you like. NOAA expecting the impact to occur between 6 and 9 Universal Time tomorrow morning. Additional CMEs did happen, by the way. We'll get to those momentarily. First, let's take a look at what's going on around planet Earth. How about Earth's magnetic moment from space? There you go. That is the past 4 hours, and it is quite calm. It is a low-pressure environment. It might be some erroneous readings again. We'll talk about that here in a minute. Keep in mind the space weather modeling framework uses whatever the active spacecraft is on the real-time space weather, on the real-time solar wind data. So showing very low pressure here. A little increase happening there. That's the last 4 hours of Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from the ground level. If you're wondering if I'm expecting Earth's magnetic poles to flip, the answer is, well, absolutely not. Do you see any quadrupoles, hexapoles, octopoles showing up on that map? No, me neither. Nobody does, because they aren't there. Next, the planetary K-index is currently at 1.33. Again, geomagnetically calm conditions. And if you're new to space weather, the planetary K-index is an average of global geomagnetism. So here we're looking at the real-time solar wind, and the instrument just changed here. It doesn't necessarily mean the one's wrong or the one's right, but what it is showing us is that, well, right here, you can see... Hey, now, what happened? Let me try that again. You can see now right here, and by the way, we don't edit these videos so they get onto your screen as quickly as possible. They are extremely timely in nature. So here you can see a much different density showing up on one instrument versus the other. Also a big difference in speed there. So that is the green line there is the ACE that's on the left. This is the ACE, and this is the Discover, having recently switched to that active instrument just a few hours prior to this video being produced. Current conditions as measured by the Discover are solar wind density just below 5 protons per cubic centimeter. Solar wind speed here nominal at 431 kilometers per second. There is a shift in the magnetic field happening here. So the field strength increased to a 14 nanotesla magnetic field. Keep in mind that is measured at Lagrangian 0.1. And the BZ has now shifted into the negative territory. So we'll see a little uptick in the KP index here, especially if that negative BZ signal continues. That is the vertical component of the magnetic field. And speaking of magnetic fields, here are the GOES magnetometers. Now the GOES magnetometers, folks, they're measuring the magnetic fields of Earth from their geosynchronous orbit at around 23,000 miles of altitude. They are not measuring the magnetic fields at Lagrangian 0.1. That's 1 million miles away from Earth, about 4 lunar distances away, as you can't measure the solar wind's magnetic fields from inside Earth's magnetosphere. So this is inside Earth's magnetosphere. The geosynchronous orbits of the GOES 16 and GOES 18 there. And a rather sudden drop there in magnetic field intensity just before midnight local time for the GOES 16, which is what this red M denotes. That's midnight local time. This is noon local time for the satellite, giving you insight into where it is located in its near equatorial geosynchronous orbit. Next, super important, the top view ecliptic plane field plot. One of the most important in terms of predictive value features that we show on the channel. And knowing how to read that data is, Well, it was really a breakthrough. This is one of the things where I immersed myself in the data, and next thing I knew, I was able to forecast things that I wasn't even aware could be forecasted. So at the moment, there have been some changes happening once again here. A North Pole current sheet popping up, which could arrive as early as later today. So that's an indication that we may see a sunspot form or rise in the southeastern limb. Earth is currently in the middle of a small South Pole current sheet. So that could change with basically no warning. Here's our line of sight field plot, and let's see what's going on there. So you should see some shifting happening there, and indeed you do. There is a bit of a magnetic tug-of-war still going on in the northeast as well with coronal holes, which we will show next. So here the sun's B field is depicted in blue. That's the field that goes through a magnet, this magnet being the closest star. El Sol, Helios, a.k.a. the local yellow dwarf. The grayscale is the gong magnetogram, and then the blue and the green and red lines, those are the north and south polar fields respectively. And here is our line of sight coronal hole plot. So we do have some North Pole coronal holes showing up here once again in the northeast. So there is some significant instability happening up here in terms of solar magnetism. Some indecision as to whether those coronal holes are north or south pole orientation, as you can see there. Let's bring up the latest image. So at the moment in the northeast, we've got a North Pole oriented coronal hole. So there's the latest image. We've got a South Pole coronal hole right in here and down here. And the rest of these are North Pole. So there's a 2-sector boundary crossings on the Earth-facing portion of the solar disk there, as the sun looks more and more like solar maximum. Next we'll move to sunspots. There is the flare monitoring system. Again, we are likely to have 2 new sunspot groups in the northeast. We'll show you high-res images of those to see if they are still intact. But it has been pretty calm for the past 24 hours. And if you look at the latest image here, we're disagreeing with the flare probability because we still anticipate the possibility of large flares up here in the northwestern limb. Again, there still is quite a bit of instability going on there, and magnetically complex sunspot groups known as beta-gamma class sunspots, probably even beta-gamma delta class sunspots setting, the most likely scenario for them to produce large solar flares. So switching from coronal holes to, this is 1600 plus 1700 angstroms. That's ionized carbon in the 1600 angstroms wavelength. 1700 angstroms is similar to a continuum. It's not a specific chemical spectra. It is similar to visible, the 1700 angstroms. 1600 angstroms is ionized carbon. And let's take a brief look at this northwestern limb, which does indeed remain the most likely place for large solar flares. If I didn't say it enough times, I'll say it again. And there were 2 X-class events depicted there in that imagery. There's an even closer view of that northwestern limb. And there was some growth happening with those sunspot groups as well. So that is what's going on. And let's move to energetic particles and solar flares. The GOES proton flux here is subsiding. What's not subsiding is this news. The Smash News Network. Least busted name in news. So there we go, subsiding of that. Those solar energetic particles can cause polar radio blackouts. Did you know this? So the largest flare of the past 24 was an M5.5 approximately. Peak flux was around 1840 Universal Time, and then earlier this morning there was an M2.49. Peak flux of that was around 440 Universal Time. Let's take a look at our flare wavelengths. So here we've put together the 304 plus 94 angstroms wavelengths. Both of those are great at showing flares. And those two M-class events did come from the northwestern limb. No surprise if you've been tuning into the channel. And if you've been tuning into the channel, congratulations on realizing it exists. We remain surprised with the ridiculous state of censorship, and not only that, but the promotion of fraud, nonsense, propaganda, disinformation, misinformation, etc. on all social media platforms. There's 94 angstroms by itself. We subtracted the ionized helium there. And how about some closer views here? There are indeed some other sunspots that are capable of producing significant flares here, folks. But again, the most likely place is that northwestern limb. What's that? You want some close-ups of the northwestern limb? I think we could probably do that. Here's another 24-hour video. By the way, all of our custom videos today are showing 24 hours of activity. It's one of the benefits of doing daily space weather. There is an extreme close-up. Yowzers. That's pretty freaking awesome. All right, so now we're going to talk about cosmology here in a minute. First, let's take a moment to step back and look at the sky a lot less zoomed in. There's a star chart of what's going on overhead. If you want to make your own, put in your location at skyandtelescope.org. And you can make a star chart just like mine. Venus trailing the sun here if you're viewing the early dusk skies. Go check out the third brightest object. Earth's twin, Venus. Next, your solar system forecast. This is where things are today. Here's where things will be in a week. People will continue to be frightened that Mars, Mercury, Venus, Earth, and Saturn are in a line, which isn't frightening in the slightest. We hope you're not frightened of... Yeah, yeah. That's where things will be on August 14th. No, the planets are not going to kill you. For goodness sakes, how much nonsense can really be believed on the internet? Here's our astronomy photo of the day, and it is a planetary nebula, perhaps a star birthing ground. And this is depicting ionized oxygen, sulfur, and, of course, hydrogen. By far the most common element in space. So the blue is the oxygen, and there is a reddish in there, that's the hydrogen, and then the yellowish color, that is the sulfur. Go check out apod.nasa.gov. The Pelican Nebula is what it's called, otherwise known as IC5070. I like Pelican Nebula better. And let's just say there's a lot of action going on in that area. A lot of action. I would say especially down here with all the sulfur. I mean, there is one very bright, large blue star there, looking like it's carving out its own little section. And by the way, here comes our cosmic ray report. So cosmic rays, these are... Cosmic rays, if you're not familiar, are ultra-high energy particles Mostly hydrogen nuclei. It is a similar chemical makeup to the solar wind. And cosmic rays, they make it all the way through all the magnetic fields in the galaxy, and they make it all the way to Earth, and they interact with things, creating particle showers. And so neutron monitors are one of the ways that we monitor cosmic ray flux. And if you're not familiar with cosmic ray flux, it is inversely proportional to solar activity. So when you have a high sunspot number, you have a low cosmic ray flux. And we've verified this going back 1,000 years at least. And it has to do with the ratio of carbon-14 versus carbon-12 isotopes. That gives us an idea of cosmic ray flux from long ago in tree rings. More on that in a minute. Here's the cosmic ray report. We're showing significant decreases in cosmic ray flux for the past 30 days at all of our major monitors. So there's Apatity, significant downtick in the past 30 days there. That is the lowest levels seen since around 2004. Here's Barentsburg neutron monitor and a similar major downtick there at Barentsburg. So this one actually is a 4-bush minimum, as it is known that solar energetic particle events are also correlated with big dips in cosmic ray flux. So that's Apatity and Barentsburg. Let's go a little bit farther south to Athens, Greece. Significant downtick in cosmic rays at Athens, Greece as well for the past 30 days. Downward trend there. Not as sharp of a downward trend, but nonetheless. By the way, if you check out the Neutron Monitor database, you can plot them all at the same time. I like to show them individually. Let's go even farther south to Mexico City. Significant downtrend at Mexico City as well. Once again, lowest levels there since around 2004. And looking at Oulu, Finland. Let's look at the Antarctica monitors first. There is DOMB Antarctica. And it's got some missing data, unfortunately, not showing that recent downtick. Same with DOMC. So it is winter down there. Who knows what's going on? By the way, if you want to winter in Antarctica, you better be a scientist and you better be able to shovel snow. Everybody that winters in Antarctica has to shovel snow nearly every day because they don't want to end up dead. You'll get snowed in and you won't be able to get out, and it's pretty serious. So unfortunately, the Antarctica monitors are not going to correlate much of anything. However, if you look at Oulu, and let me zoom in on this briefly. Look at Oulu, Finland. And right there is where the levels are. Again, the lowest levels since around 2004. So for everybody who is telling you that cosmic ray flux is at the highest it's ever been and it's just going to continue to go up forever and we're all going to die because of it, maybe show them this video. Or maybe just tell them that they're full of crap, because they are. The highest cosmic ray flux ever measured was around 2009 to 2010. There's the data, and multiple cosmic ray monitors agree with me. These are basic facts. So, and by the way, the last 30 days at Oulu, Finland, also a significant downtrend in cosmic rays. So there you have it. That's the cosmic ray report. And if you want to learn more about cosmic rays, here's a paper that we picked up on smashomash.com/forum. So it's a free forum. You can just go right in there and set up an account if you don't already have one, log in, and you can post whatever you like. We encourage all legal speech on the channel. This is just showing the solar activity through proxy data, through that tree ring isotopic analysis that I talked about earlier, because we only have sunspot observations back to about the 1700s. Before that, we rely on the cosmic ray induced isotopes. So that is a paper that is basically disproving a grand solar minimum. And you can read about, again, on smashomash.com/forum. There is a forum about the sun. There is a forum about cosmology. There's a free-for-all forum. You can even read about our mission if you scroll down to the bottom. That is our .com mission, which, by the way, is separate from our .org mission. Although you can find information about the .org mission as well at smashomash.com/forum. Because again, we are free speech purists, folks. We are not free speech phonies. We encourage all legal speech. And we're working our butts off to make astronomy and cosmology science again. Or MAXA. Yeah, MAXA. Because there are some issues. There's a revolution coming in the realm of cosmology. And I'll just leave it at that. I don't want to give too much away. However, I am in the process of composing a paper that plausibly explains the solar sunspot cycles, which will be one of the most important papers in hundreds of years when it passes peer review, because sunspot cycles are not understood, and heliophysics is the basis for cosmology. So every advancement in heliophysics is an advancement in cosmology. Don't be in denial of these facts, and help us make astronomy and cosmology science again by picking up some merch. Links to the merch shop below this video, as well as on the homepage at smashomash.com. Just click the Smasho merch link and find the Redbubble shop. Perhaps join the Croissant Earth Society, or maybe the Galactic Federation Special Forces, and tell your friends and foes, Universum Liberate. All right, let's take a look at some coronagraphs here. Here are George Mason University's coronagraph images from yesterday. And there was one significant CME there, kind of late in the day. That one may have an earthly directed component. We're going to have to do further analysis. It's part of the reason why we make these videos. I look at the data that I want to look at, and then I share it with people like you. Why? Because nobody's looking at the correct data and doing daily space weather videos, so we filled the niche. Here are today's coronagraphs, an additional 43 frames from today. And there are some outflows happening there, some minor CME activities, nothing major so far today. Expect CMEs to continue, though. So here's a quick analysis of that one late in the day yesterday. It started to show up on the coronagraphs around 1900 Universal Time, so we paused this at 1912 for the C2 and 2018 for the Soho-Lasco C3 mission. That one may have an earthly directed component. So we'll just bring those back and let them play through. So there may be another CME showing up sometime around midday on the 10th. Early to midday on the 10th, I'll say. That is the 10th of August, 2023. We'll also show stereo A, which is showing some oddly erroneous data. Feel free to pause the video in this frame if you're not familiar with the locations of Solar Orbiter and Bepi Colombo and the Parker Solar Probe, and stereo A and B depicted by the red and blue circles respectively there. Earth is the green circle. All right, so here is... Where am I? Oh, I'm in space. Hey, welcome to the Milky Way Galaxy, folks. Milky Way Galaxy team for the win. All right, so there is stereo A on the left. And again, it is showing some erroneous data there. Hopefully the spacecraft isn't damaged. I have no explanation for that. That looks like some kind of an artifact. There shouldn't be anything out here glowing like this, so it's very odd. I have no legitimate explanation for that. Let's see if we can find this CME. Should be right around now. And unfortunately, there's like 10 hours of missing, 8 hours of missing data there, so that's not really helpful at all. So that's a shame. But not to worry. We've got custom coronagraphs for you here, so let's take a look at that next before we get to filaments. And there is a filament getting named today. Mark my words. Wark my merds. There's a 24-hour video. And yeah, I think there may be an Earth-directed component there. But let's move in a little bit closer to see what kind of filamentary motions we see. All right, so maybe not. That one, that CME is derived from up here in the northwestern limb. Probably no surprise. Here's an even closer view of that. Actually, it came out of the southwest. I don't know. That one's pretty. I'm 50-50 on this one. So, but because we are sort of more like NASA with our forecasting, we prefer to forecast all CME impacts. We're less concerned about the implications of preparing for CME impacts for satellites as NOAA does. So I'll say a possible CME impact coming sometime around early to midday on the 10th. So you'll see that coming from right around down in this area here. Right there. Right there is the source of that latest possible Earth-directed coronal mass ejection. That's another 24-hour video from SDO in 193 angstroms. And moving right along to filaments. And there is certainly a significant one to get named. So here comes some hydrogen alpha imagery from El Teide, Spain. So this filament up here is getting named today. Whether you name it or I name it is up to you. It's just a matter of whether you join us on X, the platform formerly known as Twitter. Hit us up over there. Follow the hashtag #NameThatFilament. And here it is in slightly greater detail from the same ground-based solar observatory at El Teide, Spain. So that is one gigantic filament. Expect CMEs to continue going into tomorrow. The likelihood of additional coronal mass ejections is about 99.9%. So let's bring up the latest image. And once again, we'll head to X. If you haven't followed us over there, well, we recommend you do. And just give it a moment, folks. It'll figure it out. It'll figure it out. Don't worry. Just follow the hashtag #NameThatFilament. Not living hymens, living humans. There you go. Who do you think we should name the filament after? Let us know over on Twitter. They don't get named on YouTube comments or any place besides over on the platform. Now rebranded to X because reasons. Here's the past couple of hours from the GOES 16 SUVI, looking at ionized helium. And let's get into our bonus features segment. Satellite charging hazards are non-existent. It's smooth sailing for satellites. No electrons building up on or in those spacecraft. GOES electron flux here remains quite low, perhaps surprisingly low. I think I may have forecasted a little uptick in the electron flux going into today, but the ionosphere is still puffed up, so we're seeing erroneous readings likely there from the GOES 16 and GOES 18. Here is the one-year chart to put it in context. That is the relativistic electrons at greater than 2 mega electron volts. Here's the forecast model. NOAA is expecting flat levels. So I'm not so sure about that one. I think we may see an uptick here in the electron flux. Keep in mind that those electrons are mostly from Earth. I figured I'd throw that in. And they are measured at the F layer of the ionosphere. So feel free to pause the video on this frame if you're not familiar with the thermospheric temperatures, atmospheric temperatures, electromagnetic radiation penetration, and thermosphere and other atmospheric layer chemical concentrations. Here's the F layer of the ionosphere, courtesy of Australian Government Bureau of Meteorology. And we're seeing quite a lot of low-frequency anomalies once again here. Following that geomagnetic storm where we saw a KP 6.67, It's not super surprising. It usually takes a few days for that to subside, and it is. So if that doesn't make any sense to you, don't worry. It's showing vibrational frequency, which is megahertz, millions of vibrations per second. It's diffuse gas vibrating. And here it is in anomalygram. Anomaly in megahertz from a 30-day median. A lot less low-frequency anomalies than we showed yesterday. Anyway, here's the latest image. That's 12:30 universal time for the ionogram, raw megahertz. And there is the anomalygram, anomaly from the 30-day median in megahertz. Total electron content is a completely different thing. It's showing free electrons, literally a count of them from your GPS satellite to your handset. A run of about 12,500 miles. Feel free to pause the video on this frame if you're not familiar with those distances in miles. And here is the total electron content forecast. So things are fairly organized there. And of course, people who live around the equator are well aware that the most likely place to see major GPS errors is around the equator at noontime, as evidenced by this imagery. We'll also show the anomaly from the 10-day average over North America for the total electron content. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It's free electrons. Your GPS satellite has to communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. So that's, again, anomaly from the 10-day average. No major anomalies here over North America. See previous videos for when there were anomalies. We do it daily, so you don't have to run through all the data. Here's the latest intensity gram. And here's the latest high-res magnetogram from SDO. So once again, the most likely place to see large solar flares continues to be the northwestern limb. That sunspot group is quite magnetically complex. It is beta gamma delta class. It has a lot of magnetic shear, meaning strong magnetic fields that are close to each other. Here's a full disk rockback. A couple new sunspot groups might get named today. What was it? This one formed, and I think this one is a new sunspot group. I don't know. I can't remember. Never memorize something you can look up, folks. That's a quote from Einstein. And let's get to meteorology. So we used to make these videos separate, but not anymore because it just simply reduced our views on YouTube. Apparently people like lengthy videos, so I don't know. It's, I guess some people have long attention spans and some people have short attention spans, and I mean, we've got a whole list of shorts as well on the channel. Share those with your people who have short attention spans. youtube.com/smashomash/shorts. And don't poop your shorts over all this dust in the Atlantic Ocean. It makes hurricane formation less likely. So if you're looking for fear and disaster porn, sorry, it's not going to be showing up on the channel. All that dust tends to tamp down systems, preventing convective systems from forming tropical storms. Anyway, moving right along to our surface winds and jet streams. So here are the surface winds of the east. Here are the jet streams of the east. Here are the jet streams of the west. Quite a coherent jet stream here over the central U.S. Surface winds depicted here, and here are the surface winds of the central world, and here are the jet streams. Some significant bends to the jet stream there. It looks like a cold day in Scotland and a cold day in Italy. Looks like a warm day in Belarus. Shout out to Eugene the Philosopher. Make sure you subscribe to his channel. Eugene the Philosopher, regular contributor to this channel. one of the more interesting people that I have ever met. Not yet in person. We're trying to import Eugene to the U.S. So next we're looking at snow depth. And by the way, there is some significant melt here around northeastern Greenland. I don't remember that being quite as melty last year. There's also quite a bit of melt there around the northwestern portion of Greenland. However, from coast to coast, there is more than 5 meters of snow in most of those areas. So it's running out of time to melt here. In fact, there has been some new snow being deposited on Greenland recently. I'm not going to show any graphs about that. I don't want the video to be too lengthy. We'll show clouds and fog over the Americas next. That is shortwave radiation that allows you to see clouds and fog at nighttime when the visible satellite shows you nothing more than a dark disk. Next, your smoke map forecast. This is firesmoke.ca. In the northern part of the country, they're seeing quite a bit of smoke, not super dense, except over places like Washington and northern Idaho. Also, western Oregon, they're seeing some significant smoke. And let's move on and blast through the rest of our weather coverage. Space weather, Earth weather, we got them both. Here's your National Weather Service map from weather.gov. High wind watches there around Hawaii. And some, what is that there? That is, I don't know what that is, but there are some warnings there. It looks like dense smoke in Alaska. I don't know. Anyway, if your location is lit, head to weather.gov and click it. We've got heat advisories for most of the southern part of the country. Some floods also showing up there, so let's show some temperature anomaly forecast. This is the GFS 72-hour temperature anomaly forecast in degrees Celsius. That's what's going on thermometers, likely in the next 3 days. We show 3-day forecasts because they tend to be accurate. Here's a 72-hour GFS total accumulated precipitation forecast in inches. And check it out, Maine is going to get kaplastered, also Nova Scotia. Shout out to Ricky, Julian, and Bubbles. Going to get kaplastered there with some really heavy rains for a huge area there. 3+ inches. Over hundreds and hundreds and hundreds of square miles. We also like to show the pressure and precipitation forecast for the same model, the GFS 72-hour. And the jet stream forecast. Again, GFS 72-hour. So jet stream's going to move up north. Expect a little higher temperatures coming to the U.S. there. Again, the jet stream is expected to move back up toward Canada and mostly stay north of the U.S. in about 3 days. So that's what's going on. Here's your lightning mapper. That's the past 10 hours. Heaviest lightning here was across Illinois, Indiana, and then some rapid formation sweeping across Oklahoma into Arkansas. Here's your current lightning map from lightningmaps.org. Lightningmaps.org. Next time you hear thunder, I highly recommend it. We do have some active cells here in Arkansas and Oklahoma. They are minor thunderstorm activities there. And some single lightning bolts happening here in Central Africa and the Atlantic while we produce the video. If you enjoy the content, consider becoming a member of the Smash Team. SmashOmash.com/Smash Team is our subscription services site. We replace Patreon with a superior site. If you want additional content, become a Smash Team member. You'll get email alerts even at the bronze level, and you'll even get additional content at the bronze level. Join at the silver level or gold level if you actually want to support the channel. The best value is the gold annual paid up subscription. So smashomash.com/SmashTeam. Join us over there. Again, additional content, all sorts of benefits for the Gold Smash Team level members. And if you are a Gold Smash Team level member, why not leave a comment and let us know? By the way, these videos are brought to you in part by our Smash Team members, as well as at massive personal risk and expense by Smash staff and I, as we attempt for the past 6 years to make this channel sustainable. So help us out there. Links on the homepage at smashomash.com. Hit us up on social media. Press that share button. Press the like button. Oh, you haven't pressed the like button yet? All right. I'll wait. Here at the Smash News Network, least busted name in news, I behave as if I have patience. So that's really what it boils down to, folks. We don't encourage people to be patient. We encourage people to behave as if they have patience. So ultimately, that's what it boils down to, right? You can think crazy thoughts all day. Just don't do crazy actions, and you should be fine. All right, so here's our final segment. This is U.S. Doppler radar for the full 50-state view. Shout out to Brett in Anchorage, Alaska. Haven't heard from you for a while. Hopefully you're doing well. Here's a lower 48 view. Here's clouds and fog, 3.9 micrometer infrared radiation. The shortwave radiation map from the NASA GOES Interactive Weather Satellite Suite. And of course, the most definitive thing is that water vapor map. So it looks like clear skies over southeast Texas, although there is some moisture moving across the state there. So huge pressure gradients being created here as this little bit of moisture strikes this basically blocking feature right here. That is a relative high pressure zone. That is a relative low pressure zone because of the molecular mass of water vapor versus N2, atmospheric nitrogen. Anyway, here's a recap. That is a U.S. Doppler radar map. If you're not familiar with Doppler radar, it's a ground-based system that depicts vertical motion in the air column. Here's infrared radiation from space-based systems in the infrared spectrum. 3.9 micrometers is the frequency. And last but not least, there is the water vapor map. And here is me closing this thing out, thanking you for tuning in, being once again surprised that you found the channel. So don't forget to press those buttons like, share, etc. In fact, let's go one step further. Unsubscribe from the channel today. Yes, unsubscribe today. I blew myself out. All right. So anyway, I'm out of here. Got to get this video uploaded so it's on your screen in a timely fashion. See you soon. And in the meantime, may that solar wind be at your back. I'm going back into space again.